I will talk to you about Solr's missing plugin ecosystem. And we will do an introduction. I will try to explain what plugins are today, and then go into a proposed new system for Solr plugins, and close with a more technical deep dive. First, a little bit about myself, Jan Høydahl, 45 years old, 2 kids. That's much of the reason I haven't seen you guys for a few years, because I haven't prioritized, at least not overseas traveling. I'm a Lucene Solr committer. Is there a problem with the sound? And my background is roughly 5 years with telecom, real-time programming, 5 years with fast search and transfer, commercial search vendor in Norway that got acquired by Microsoft in 2008. I had a few years running a startup. Didn't go that well, so I fell back to becoming a Solr freelancer for the last 10 years. So that gives me 17 years all in all in search. This is beautiful Oslo. We have a brand new skyline. And if you don't know where Norway is, it's on the top of Europe. This is one of the tourist attractions in Oslo, the Vigeland Park. Have any of you been there? No. You're welcome to come and see. And this monument is called the Monolith. So am I saying that Solr is a monolith? Yes? No, I'm not saying that. Solr is actually quite modular, but I think we can improve in some way, and that's, we'll come to that. I say the Solr plugin ecosystem, but what is an ecosystem in this context? The technology ecosystems are product platforms defined by core components made by the platform owner, and complemented by applications made by autonomous companies in the periphery. So that's pretty well. So do we have an ecosystem for Solr already? Is it flourishing? Is it successful? Of course, there is an ecosystem. We have Solr, we have Apache, and other Apache projects using Solr. We have the developers, the committers, we have independent software vendors integrating Solr, shipping products based on Solr. We have users, we have the open source and GitHub communities. And you find pieces of Solr integrations, here and there. So there is an ecosystem. But we want it to grow and to flourish and to succeed even. Let's talk about Solr plugins as it is today. We will look at what the plugin is, how it is loaded, how we distribute it to the users, and we also conducted a poll in front of this talk. Did any of you take it? Yeah, one. And we'll look at the results from that poll. A plugin, it's a very overloaded word, but there are primarily 2 ways to think of a plugin in this context. In Solr, it's a Java level class, which you can override or plug in yourself. But maybe the more common use of the plugin term is to have a feature packaged up for you as a plugin. So we'll use both of those, but just so you're aware of the distinction. What is a Solr plugin? So in Solr, we will mostly use the Java level definition, and you can extend many parts of Solr through writing your own Java classes. This diagram is my attempt to make a simplified architecture diagram of the internals of Solr. On the left-hand side will be the updates flowing in, and the right-hand side will be the queries coming in, ending up in Lucene at the bottom. So some examples of Solr plugins would be query parsers. There are many examples of query parsers and also custom ones, third-party ones out there. Update processors, very, very easy to write your own update processor to modify the documents as they flow into Solr. Search components, more or less the same on the search side. You can modify the query before it hits Lucene. Response writers to control how the results are delivered back. For instance, XML, JSON, Python. And of course, in Lucene, you have tokenizers, token filters, and so on. And there are many more. So we already have a lot of places where we can extend Solr. And of course, we have the contribs. You all know data import handler, learning to rank framework, which is actually a contrib, and the response writer. So contribs are a little bit more than just a Java class. It's typically a jar file that you can find in the dist folder, and it will have dependencies or other resources in the contrib folder. And it's a separate entity, very isolated, so you can plug it into Solr. But it's not one file. So in Solr, how does Solr load a plugin? If you have a plugin and you want it to be picked up by Solr, of course, it needs to be found on the class path. In Solr, we have something called a resource loader, which you can also ask to find classes and resources, which in turn has a class loader that will look in predefined places in the web app, in the Solr home/lib, and you can also hook up your own custom locations in Solr config with the lib tags. And then once you make sure it's on the class path, you can simply name your class in whatever config file that you want to plug it into. And then it should load, or maybe it doesn't load. And you end up debugging and finding, oh, why didn't this load? Class not found exception, and so on. This particular error message is for the velocity response writer, and it's a little bit special because it's lazy loaded. So you don't get a warning until you try to use it. And then the system will try to find the class dynamically. So it could be a bit trappy. How are current Solr plugins distributed? Well, of course, a lot of the plugins are actually in the Solr core itself. Some of the plugin classes will be in the contribs. And all of that is shipped together with Solr, so it's quite easy. One big distribution. Then you have a few third-party plugins all over the net, in GitHub and elsewhere. And you even have someone who tried to make a catalog over all the available plugins out there, and to list them and to point to where you can download. So it's kind of the ecosystem isn't completely missing. So it's a bit overstatement, but it's still a bit tricky maybe to find all the plugins. So we asked you to answer a poll on how you use plugins, what you think about the Solr plugins. We got 32 respondents. I would have liked for more, but take it for what it's worth. A few committers, some developers, some operational guys. And what did you answer? So what plugins are you using today? Not very surprisingly, the top used plugins are the contribs. You also find some plugins there from Sematext, from Shopping24, and some other third parties as well, which is good. Then we asked you to rate a few statements. And I'm plotting it as agree would be the green bar, disagree would be the red bar. So are Solr plugins easy to discover? And you think, no, you disagree. It's not very easy. What about install? It's somewhat better. It's not too hard to install a plugin, but it could be easier, right? There are some disagreements here as well. And then, are they easy to configure? Both yes and no. It could be better. Do you recognize? Do you agree with this? What about upgrading? It's pretty hard. It's doable, but yeah, it's a pain. What about matching the correct plugin version to the correct Solr version? Well, often it's documented that for this version of Solr, you should download this version of the plugin. So it's not really hard, but it's maybe a little bit cumbersome. Do you find a plugin for all your needs? And you really disagree? So there could probably be more plugins out there than what you're able to find today. Is it easy to develop your own plugin? Yeah, not so bad. Is it easy to distribute it? Not so much. Okay, and then we asked you to prioritize what of these features would you most like in a new plugin system. And the top three were like a Solr hub experience, where we have a repository online where you can download plugins. And number two, distributed install. Click a button and you install a plugin on all the nodes in the cluster. And three, command line interface support. And there are other options as well. But nobody said that it's important that it's an OSGI compliant thing or a Jigsaw compliant. So I don't know. We also had some questions to the developers. Do we need a Solr plugin SDK? Yeah, not a bad idea to help people get started. Should all plugins strictly be committed in the Apache Git? No. We need others to contribute as well. So GitHub is probably a good idea for many plugins. Should we have commercial paid plugins in the repos, in the official repos? You see disagreement. I can guess who says yes, those who develop those, right? And the current plugin types are sufficient. So do we need more extension points? And probably we need that. It should be possible to develop a plugin in another language than Java. I don't know why I asked that question, really, but how would that look like? So I don't know. So that's Solr plugins today, and what you think about how it works. So let's introduce the improved. We'll start by looking at the proof of concept that I developed, and then we'll look at benefits of having such a system from the end user perspective, and from the developer perspective, and then from the project or product perspective. It all really started with this Jira 5103, made by Grant Ingersoll when he was still coding. And it's been laying there since, what, August 13? And nothing has really happened, right? So this is a hope to revive this work and to get something out there. So I decided to make a proof of concept. This is really just a pet project on the side because I've been thinking of this for a long time. So I decided to make it works to show that this is one way to do it. And I've integrated PFJ, plugin framework for J. We'll talk more about that later. There is a design document in Google Docs that you can have a look at. Some of you already commented and contributed there. The patch is 10.665. It even has a link to a download, so you can download a tarball and try it yourself. There is a command line interface, bin Solr plugin, that you can use to interact with installing and so on. And there is also support for repositories where the plugins can be hosted. So let's look first at the end user perspective. How is the experience for the end user? Starting from download of Solr, and then to discover what plugins are there, to download and installing them, and also to keeping the plugins up to date. The first is download. So users download a very slim core without any contribs, huge analyzers, esoteric query parsers, just a few megs. That kind of a vision. We want a lean core distribution of Solr. How does it look today? The download is about 140 megabytes. And the core part of that is about 50. You have a bunch of contribs and test framework and large analyzers and that maybe very few people use and so on. So if we shave off a lot of these and make them into plugins, we can reduce the size by 65%. And if it takes 1 minute to download Solr 6, it could take maybe 20 seconds to download a future version, which has a slimmer core. It will help us to escape the kitchen sink syndrome that we're kind of having with Solr. And going forward, we could even shave off more features into plugins. Next is the end user experience for discovery and installation. And the vision there would be a new plugins tab in the admin UI lists available official plugins as well as community plugins, installable with a single click. That's a nice sales statement, right? Okay, so how does that look like? Here we go. At least a draft version of admin UI. You see there is a new plugins tab in the admin. And it's really ugly, but it just lists all plugins available from all repositories. And you have an install button, which actually doesn't work. But it's a start. And if you prefer to use the command line interface, it could look like this. So you have a shell, and you say bin Solr plugin search Anna. And you see there are 2 plugins matching analytics and analysis. And you list them with only the IDs, -I, and you decide to install both of them. Solr plugin, install analytics, analysis extras, and then you can issue bin Solr plugin list to see what plugins are installed. With the I, you only get the IDs. Without the I, you get the table. And yes, they are installed. And this is actual recording from my from the proof of concept. How about staying up to date? When you have a new version of Solr, you might need a new version of the plugin, or if there is a new version of the plugin or bug fix, you want to get it. So what would the vision be? You will, with a single command, upgrade to the latest version that is compatible with your Solr version. Make sense? The usage for the command line interface gives you an outdated command that you can list what plugins are outdated. There exists a new version already in the repositories. And by using the upgrade command, you will upgrade them. Disable the old one, pull the new one from the repository, and install it, and activate it. The only catch, maybe, is that upgrading replaces the class loader and puts it in there for the plugin. But the rest of Solr, which may be using that plugin, is not really built to have things change underneath of it. So you need to reload. The core using it, maybe reload more components, or maybe even the whole instance. So that needs to be solved. Let's look at the developer perspective. First, what I call the App Store advantage for developers. Of course, you get visibility of your work and distribution. So you can reach much more people. And simpler documentation. Who of you have followed the 10 bullet list to install a plugin? You know, do this, do that, download, put it there, add a lib tag, and so on. So now the only documentation would be just run this one-liner, and it's installed. Upgrades, as we just saw, the upgrade will do the version checks and find the latest supported version of the plugin for your version of Solr. It will also do the checksum after downloading the binary. It will validate the checksums to see that it's the correct one. And for the official plugins, we will also validate the signatures. And then maybe the controversial part, ability for a developer to get paid plugins out there in the hands of the users. Maybe try before you buy, freemium. So I'm not proposing an app store where you actually pay things. It's a very, very simple repository concept, but having this ability for a developer could be intriguing. Last, we'll look at the fits for the product and the project. And we already talked about the kitchen sink. We tried to solve everything with one download. Could be better to have a smaller core and faster downloads, and then have modules that you can add. About attracting developers to the project, all the developers out there who have ideas or users who build plugins for themselves can now have a wider distribution, which might give them a better sense of community and help them become tied to the Solr ecosystem in a stronger way. When it comes to modularity of the product and the code base itself, as people start writing plugins for all different kind of use cases, they will probably meet some obstacles. And it will help us to make new extension points. It will help us to break out features into plugins. Very typical that you have a Jira. It has a patch, it's working, but no, we cannot put that into Solr core. It's either too big or it's not good enough or ready or whatever. Maybe it could start its life as a plugin somewhere else. And then as it grows, maybe it will come into Solr core at a later time, or as an official plugin developed by the committers. And then we have licensing issues. Dependencies being GPL. In the geospatial thing, we have had that case. You need to go somewhere to download dependency because we're not allowed to distribute it. But we are allowed to have a GitHub having that dependency being pulled by the user because the user does the action. Okay, so that was an introduction to the functional and the benefits of the system. Let's look into the details of the technicalities. We'll talk about the choice of plugin framework. We'll talk about how the new plugin bundle looks like, the plugin repositories, and some challenges. First, when you make plugins, shouldn't you use OSGI? Of course. But it's quite heavyweight. I imagine it would take forever and maybe never be finished. But then again, I don't know OSGI well enough, but I decided no, I'll not go that direction. Java 9, Jigsaw. Oh, isn't that the perfect solution to replace OSGI and everything? But it turns out it's not. It solves a different problem. It's more for modularity of the JVM. It doesn't have anything of the repository stuff or version dependencies or anything. But there is a project, PF4J, and Jigsaw is is not yet released either. So PF4J, plugin framework for J, it's lightweight and it's customizable. You can extend anything and just rewrite the logic, which fits us quite nice. And it provides versioning, dependency checks, and the repository feature. So we selected it. Can we take questions at the end? If there's time. So, PF4J, what is it? It's a project out there on GitHub, and it's also pf4j.org. It's quite many forks and stars. They say about themselves, PF4J is an open source, lightweight plugin framework for Java with minimal dependencies and very extensible. And there are even other projects out there already using it. So we're not reinventing the wheel or trying to build something from scratch. It's also fairly active. It's been around since 2013. And, you know, it's quite healthy. Apache licensed, which is also nice. So then, the plugin bundle. What would that look like? The new way of wrapping up a plugin. It's defined by PF4J. And we simply just drag in the framework through our Ivy dependency. A plugin is then a jar with a manifest. Quite simple. It's just an extension of the manifest. Or it could be a zip file, also with the manifest, but in addition to the classes, you also include all the dependency libraries. The plugins will live in Solr Home in a folder called plugins. And that also allows one install of Solr to have different instances with separate plugins, since it's in Solr Home. Let's look at the analysis extras rewrapped from a contrib into this kind of plugin bundle. As you see, you have a classes folder where you have a manifest, and you have the classes for the plugin. In the lib folder, you have all the dependencies. Basically, what is in the classes folder is what's in the jar file in dist today, and what's in the lib folder is what's in the contrib folder for analysis extras. So it's very easy just to package it. Looking at the manifest, we see that we have a plugin ID defined, which is the one you will use when you reference it. You have a version. You can optionally also specify the license and a Solr version requirement, which will be used for computing which version of the plugin to pick, and some other metadata. The same would be if you package it as a jar, the same format of the file, the manifest. Let's look at bootstrapping. How do you start the framework? Core container will check system property. Should you start the framework or not? If you should start it, it will start the plugin bundle manager, and then some class loaders. We'll not discuss the rest of the diagram here, but we'll talk about class loading. Because today you have Solr resource loader, which has a class loader that already looks in the lib folders and in the webinf lib and so on. So I decided, at least in the proof of concept, to make a plugin bundle class loader that's aware of all the plugins that are currently active, and to replace the class loader in Solr resource loader with my new one. And then add a link to the old class loader as the parent. and this is the parent first class loader, so everything will be the same. So when someone asks Solr resource loader about find the class for me, it will first look where it used to look in the rest of Solr before it tries to iterate through all the plugins to find the same class, which I think makes sense to not suddenly pick up the wrong class. It works the opposite way. When a plugin requests a class inside its plugin class loader, then it's depth first and parent last. So it will first find the dependencies that it ships with before it tries to go into the rest of Solr to look for it. And it will also, by the way, work with Zookeeper resource loader because it's the same, you know, everyone who uses the resource loader or the class loader from the resource loader will just work without any more code to, if plugin, look in the plugins, if not. Let's discuss plugin repositories. The same here, it's a separate subproject, pf4j update. Any static website or folder will make a repository. So it's really simple. You don't need to install any programs. You just need to make a plugins.json file that will list all the plugins. And also in this file, you will have version specifications for what version it requires from Solr. We propose to make several different repositories. An official Apache repository that will look in the dist Apache area for plugins that we ship. Community moderated plugins that live in GitHub. User can add their repositories themselves, either from GitHub or from a website. You could even have a local file share in your organization where you put all the plugins that your Solr cluster should be able to use. Or you can do it manually. Just drop the plugin jar or zip into the plugins folder. Looking at the Apache distro update repository, it's just subclassing pf4j's update repository. And it will look first for plugins in the closest mirror. If it couldn't find it because maybe it's a too old version of Solr, so it's not there anymore, it will start looking in the Apache org central dist folder. If it's not there, it will go to the archives and pick up the plugins for that version of Solr. Also, it will validate the checksums and also the PGP signature before allowing it to be installed. So to avoid some man in the middle or which one? Validate against the MD5 SHA files that we publish in the distro. So we can talk about it afterwards, but at least we have that possibility. So currently I've implemented the validation of the SHA checksum, and I haven't really solved the validation of the PGP signature because Java needs some extensions to work with the strong cryptography, but it's probably solvable. So wrapping up, we need some more research. It's just the first few steps. Versions of jars, jar hell, probably give us some headaches. How to distribute installation to all the nodes in the cluster. So far, I just say that, okay, you have to do it on each and every node as part of the rolling upgrade to simplify things. How about the blob store, runtime lib? We'll have to look in, maybe we can utilize that to upload the jars to the .system collection. And the thing that after a plugin upgrade, you really need to restart all the components that could possibly use that plugin. So find a way to do that maybe automatically after the upgrade. And also maybe plugins could contribute more than Java code, contribute to the UI, a lot of possibilities. We could also add to each collection a dependency tag saying that this collection is designed to require this plugin. So it will not start unless that plugin is installed. Or maybe even give you option of automatically installing the dependencies. In addition to the zip and the fat jar option, we could also have a slim jar and have the plugin system go to the Maven system to pull the dependencies automatically. Would be pretty cool. Use SPI for loading classes more, and make a SDK for samples to get started. So the next steps that I propose is to split the POC up into smaller JIRAs and start developing the core features first. Commit something to master, let it bake, and then split out a few contribs into plugins, and release some version of Solr with this limited plugin support. And later on, split out even more features and slim down the core of Solr. Short recap, and hopefully we'll get some time for questions. Solr is already quite modular. It's not a crisis, but it could be better. The kitchen sink syndrome, we try to do everything in the same download, and it's pretty hard to know where you should go to look for third-party plugins. So in this talk, I presented integration with PF4J plugin framework to solve this, and it will provide a well-defined plugin bundle. It will provide tooling to work with installing and upgrading plugins, and an app store approach to distributing plugins. Hopefully, it will give us a larger ecosystem and a more healthy one for plugins. And that's what I had. So we have 3 minutes for questions. Anyone? Yeah. So the question is, wouldn't it be better with OSGI because it handles all the, you can have several versions of the dependencies, and one plugin could have one version and the other one another version. It's the hard, I think it's one of the hard parts. PF4J solves it partly, I think. They are still working on becoming even better. There is some isolation because each plugin will have its own class loader, and it will look inside before it tries to go outside. But yeah, we're not reinventing OSGI. This is much, much simpler, much, much smaller, and easier to get an overview of. Actually, you can just look at P4J and you can get a feel of the whole system in just a few hours. So. Yeah. Yeah. So it's possible that now I see. The question is, what if you have multiple collections and one collection wants to use a certain version of a plugin and another collection wants to use a different version? And in this first proof of concept, I haven't done that at all. All the plugins are shared across the whole instance, so they have to use the same. Of course, you can imagine that there could be differences between versions of the plugin, and you need to handle that. But yeah, it's an open question.
Yeah, and just for the plugin, imagine you have this one plugin being changed, version 1
Yeah. Yeah, so the question or the comment is that today you have really a core level concept of a plugin, and you can reload one core and it will kind of recreate its things. When we go on the system level, you will need to restart everything every time. Yeah. So, but it's a good comment. Maybe we should look into having the possibility of different versions per, or different plugins per collection. I don't know. It's hard to repeat all you say for the video, but yeah, it's valid points, all of these. I really try to simplify in the first version, and then, I invite everyone to contribute and to find the best ways to make this usable for the most of the users. And the time is up, so I'll have to say thank you very much. I'll be here for questions, and here are some references, so go look at the Jira, test it out. Okay, thanks.